Welcome back to our Python learning series. In this episode, we are starting one of the most important and powerful concepts in Python programming, and that is functions. Functions are used in almost every single program, in every application, in every system. Whenever something happens inside a computer, some task, some calculation, some repeated action, a function is working behind the scenes. Functions help us organize our code, avoid writing the same logic again and again, and make our programs cleaner and easier to understand. By the time we finish this episode, you will know what functions are, why we use them, how they work internally, what parameters are, how return values behave, what scope means, and how functions make complex programs simple. What are functions? To understand functions clearly, let us relate them with real life, because we perform functions every day without thinking. When you press a switch, the light turns on. Your action triggers a series of steps in the electrical system. This is similar to calling a function. When you say make tea, you already know the steps. Boil water, add tea leaves, then add milk, then add sugar. This is a function in real life, a reusable set of steps. When you order food from an app, the app follows a fixed workflow. It takes your order, confirms the payment, informs the restaurant, and shows delivery tracking. That is also a function, a defined set of steps grouped together. So, in very simple words, a function is a reusable block of work that performs one specific task. Python uses the same idea. A function in Python is a group of statements that work together to do one job. You write the function once, and then whenever you want to perform that job again, you simply call the function instead of rewriting the entire logic. Functions help you write cleaner code, avoid duplication, fix logic in one place instead of many, break down big programs into small understandable parts, and express your ideas clearly. You can think of a function as a small machine. You give it some input, it performs some work inside, and sometimes it gives you an output. And you can use this machine again and again without rebuilding it each time. Why we use functions? We use functions because they make our programs cleaner and easier to manage. Whenever you write the same logic again and again, your program becomes long and difficult to maintain. Functions allow us to write that logic once and reuse it anywhere we want. Imagine you are building a project where you need to calculate the total bill in different parts of the code. Without functions, you might write the same calculation many times. If one day you want to change the calculation, you will have to modify it everywhere. But with a function, you update the logic in one place, and the change is applied anywhere the function is used. Functions also help you break complex programs into smaller, understandable pieces. This makes your code easier to read, easier to debug, easier to test, and easier to share with others. Functions improve the structure of your code. They allow you to work step by step. They give your program a clear flow, and they help you avoid repeating yourself, which is one of the most important principles in programming. So in simple words, we use functions to save time, reduce errors, and write clean, professional Python code. How functions work internally. Before we understand how functions work inside Python, let us first look at the structure of a function. Because once the structure is clear, the meaning and the flow become very easy to understand. A function has three main parts. The first part is the function header. The second part is the function body. The third part is the function call. The function header is where we define the function's name and mention if the function needs any input values. This line tells Python that a new function is being created. Inside the function body, we write the actual steps or instructions that the function should perform. These steps can include calculations, printing, repeating tasks, or any logic needed for the job. The entire body is indented to show that all these steps belong to the function. Then comes the function call. The function does not run when we define it. It only runs when we call it. So the call line is extremely important because it triggers the entire function to start working. Now that we understand the structure of a function, let us move to the flow of a function. The flow begins when the function is called. Python first looks at the name of the function and matches it with the function that was defined earlier. If the function needs inputs, Python collects those inputs at the time of the call. Python then enters the function body and starts executing each line one after another. If the function has a return statement, Python prepares a value and sends it back to the place where the function was called. If the function does not have a return statement, Python still completes the steps inside the body and comes back after finishing everything. So the flow is very straightforward. Define the function, call the function, receive the inputs, if any, execute the body line by line, return a value if needed, and then come back to the main program. This is how a function works internally from start to finish. It is a clean process where Python remembers your function, waits for you to call it, and then performs the steps exactly as you wrote them. Understanding this internal flow helps you write stronger, clearer, and more organized code. Now that we know the structure and internal flow of a function, let us understand parameters in detail. Parameters are one of the most important parts of a function because they allow us to send information into the function. Think of parameters like placeholders. They are empty containers waiting to receive values when the function is called. When you define a function, you simply give names to these placeholders. You do not assign them any real value yet. The real values are given when the function is called. These real values are known as arguments. Arguments are the actual data that you pass to the function during the function call. These arguments fill the placeholders known as parameters. For example, if you have a function that greets a person, you may define a parameter called name. At the time of calling the function, you pass a real name such as Rohan or Priya. The parameter name becomes Priya during that function call, and the function prints a greeting using that value. This is the purpose of parameters. They allow your function to work with different data each time you call it. You can call the same function many times with different arguments, and the function will behave according to the input you provide. Parameters make functions flexible. Without parameters, a function would always do the same task in the same way. With parameters, the function becomes dynamic. It can behave differently depending on the values you pass. And let us understand this flow in a simple way. Define the function and choose parameter names. Call the function and pass arguments. Python matches each argument with its corresponding parameter. Python then executes the function using those values. This matching step is very important. If you pass two arguments, your function definition must have two parameters to receive them. If the count does not match, Python will show an error. Parameters also help in writing cleaner code. Instead of creating new functions for every small difference, you can use one function with parameters and handle multiple cases. So in summary, parameters allow us to send data into a function, make the function reusable, and help the function behave differently for each call. Now let us understand return values in functions. Return values are extremely important because they allow a function to send a result back to the place where it was called. Think of it as the function finishing its work and handing you the final answer. When a function uses the return statement, it is basically saying, I have completed my process, and here is the output you asked for. The moment Python reaches a return statement, it immediately stops executing the remaining lines inside the function. It then sends the returned value back to the caller. To understand this better, let us compare with real life. Imagine sending someone to the shop with a list of items. They go, collect everything, and then return to you with the result. That final moment where they hand over the items is like the return statement in a function. It signals that the task is done and the result is ready. In Python, the return statement helps us capture the output of a function. For example, if you create a function that adds two numbers, you can return the sum. When you call that function, Python gives you the result, and you can store it in a variable or use it directly. This makes your code powerful and reusable. Here is the flow. You define the function and mention a return statement at the end. You call the function and pass any required arguments. Python executes the function line by line. When Python reaches the return statement, it sends the result back and stops the function execution. The returned value can now be used anywhere outside the function. It is important to remember that once a return statement runs, nothing after it inside the function will execute. Return marks the end of the function's work. This is useful because it gives you precise control over when and how a function completes. Functions can return numbers, they can return text, they can return lists, they can return multiple values, or they can return nothing at all, in which case Python automatically returns a special value called none. Return values help us separate calculation from display. This means a function can focus only on computing something, and you decide later how to print it, store it, or use it. This separation makes code much cleaner and easier to maintain. So, in summary, a return value is the final output of a function. It signals the end of the function, sends the result back to the caller, and allows your program to work with that output in flexible ways. Types of functions. Before we move forward, let us understand the different types of functions that Python allows us to create. Knowing the types makes it easier to choose the right kind of function for your problem. The first type is built-in functions. These are functions that Python already provides for us. Examples are print, input, len, type, and many others. We can use them directly without defining them because Python has already written their logic. The second type is user-defined functions. These are functions that we create ourselves. Whenever we want to organize our logic or reuse a block of code, we write our own function. We decide the name, the parameters, and the work that the function will perform. This is the type of function we have been focusing on in this episode. The third type is functions with parameters. These functions accept values when we call them. The parameters act like inputs that the function uses to perform its work. This gives the function flexibility because it can behave differently depending on the values provided. The fourth type is functions without parameters. These functions do not take any input. They simply perform the same fixed work every time they are called. We use this type when no external data is needed to complete the task. The fifth type is functions that return a value. These functions finish their work and send a result back using the return statement. We can store the return value, print it, or use it in other calculations. The sixth type is functions that do not return anything. These functions only perform an action inside the function body, such as printing something on the screen. When they finish, they simply end without sending any result back. These different types make functions flexible. We can choose whether a function needs input, whether it sends output, or whether it just performs a fixed task. Understanding these types helps us structure our programs more clearly and more efficiently. Real-world example: calculating the total bill. We will take a very simple real-world scenario. Imagine a shop where we want to calculate the total bill amount for a customer. The bill is created by adding the price of multiple items. This is perfect for understanding different types of functions. We will solve this same problem in 4 different ways, so you understand how functions behave depending on whether they take input or return output. First version: function without parameters and without return. In this version, the function does not take any value from outside. Everything is written inside the function. The function also does not return anything. It only prints the result on the screen. On the screen, I am writing a function that simply adds 3 fixed item prices. Inside the function, I am creating 3 item values. Then I'm adding them together. Then I'm printing the final bill amount. Now let's understand the flow. When I call the function, Python enters the function body. Python reads the first line and creates the first price value. Then Python creates the second value. Then Python creates the third value. Then Python adds all 3 values together to get the final bill. Finally, Python prints the bill amount on the screen. After printing, the function ends. There's no return statement, so Python does not give anything back to the caller. This kind of function is useful when the task is fixed and does not depend on outside information. Second version: function with parameters but without return. Now let us modify the example. This time, the prices of the items will not be fixed inside the function. Instead, the function will accept values from outside, but it will still not return anything. It will only print the result. On the screen, I am writing a function with 3 parameters. These parameters act like empty containers waiting to receive the item prices. Inside the function, I am adding the values and printing the result. Now let us see how Python behaves. When I call the function, I pass 3 actual price values. Python takes those 3 values and fills the parameters with them. Then Python enters the function body, it adds the three values, it prints the final bill amount, and then the function ends. Notice how this version is more flexible because we can now calculate different bills simply by passing different prices when we call the function. Our third version, function without parameters but with return. Now let us look at another version. This time the function will not take any input, but it will return a result instead of printing it. Inside the function, I am writing fixed item prices. I am adding them, but instead of printing the final bill, I'm returning the value. Now let us understand the flow. When I call the function, Python enters the body and calculates the total bill. The moment Python reaches the return statement, it stops executing the function. Python then sends the final bill amount back to the caller. Outside the function, we can store that returned value in a variable, and then we can decide what to do with it. We can print it, we can use it in another calculation, or we can apply some discount. This type of function separates calculation from display. The function only computes. The main program decides what to do with that result. Function with parameters and with return again. And now let us create the most powerful and flexible version. This function will take inputs and also return a result. This is the version used most commonly in real programming. On the screen, I'm writing a function that accepts item prices as parameters. Inside the function, I add these values. Then I return the final bill amount. Now let us follow the flow. When I call the function, I pass the actual prices as arguments. Python takes those values and assigns them to the parameters. Python executes the function body. Python calculates the total. Python reaches the return statement and sends the total back to the caller. The main program receives the value and stores it. Now I can print the bill, apply tax, give a discount, or use the number anywhere else. This version is the most flexible because the function uses inputs to perform the work and gives back an output. It allows maximum control and reusability. You can call the function with any prices and the correct bill will always be calculated. Summary of all four versions. So we solved the same real-world problem of calculating a bill using four different types of functions. Each version behaved differently depending on whether it accepted values or returned a value. A function without parameters and without return does a fixed task. A function with parameters allows different inputs. A function with return allows the result to be reused. And a function with both parameters and return gives the highest flexibility. This shows how functions make your program clean, powerful, and reusable. In the next episode, we will build on this knowledge and move toward writing even more structured and powerful programs. Every new concept will connect smoothly with what you learned today. Thank you so much for watching and for learning with me. Keep practicing, keep experimenting, and keep improving your coding skills one step at a time. I will see you in the next episode. Take care.